knowledge that the moon is a cratered ball of rock. Stunning as it is in the night sky or in photographs taken from orbit, the landscape is barren, gray, dusty, and dark. Are there other things to be found than meets the eye? I'm Alana Bartolini from ESA Education, and joining me today is moon scientist Alexandre Meurisse. Thanks for being here with me.
Hello.
Tell me, do we expect to find any other useful materials on the moon than dust and rocks?
So yes, an important resource at the moon would be the sunlight first, as we expect solar panels to power all our activities during our lunar exploration. The only issue is, of course, it's the cycles of day and night is very different at the lunar surface than what we're used to on Earth. If you are on the equators at the moon, you will have about 2 weeks of sunlight followed by 2 weeks of complete darkness. But if you go towards the poles, you will have sunlight all the year. And next to it, you will have permanently shadowed region, permanently shadowed craters, where craters which have never seen light in billions of years. So these are very cold craters. And actually, the temperature in this crater can go down to minus 200 degrees. And we think that water may have been trapped there, because as comets travel into space, some pieces may have fell into these craters over time, and the water which have fell would have accumulated in these craters. And we are not sure yet about the form of this water, but from the satellite images, we are pretty sure it's there. We have good evidence for it. If we could use this water, it would be an important resource. As the rest of the moon is completely dry, there is no atmosphere, there is no water. It's complete vacuum actually, but this vacuum can be challenging to deal with, but it can also be beneficial for some instrumentation. So it can be seen as a resource. And another resource could also see the difference of temperature, because during the day it's about 200 degrees at the surface, but during the night it's minus 150 degrees. So these changes in temperature, we can also use it to create electricity. But actually the real resource remains the dust and the rock. But it's not more than the dust and the rock itself, the resource is hidden inside, as these rocks are made of oxygen, are made of metals inside minerals, because the soil is what basically you can find is very similar to what you can find in volcanic region on Earth. And that's actually the real resource of the moon.
Okay, so how do we actually make use of these materials?
So this dust and these rocks, it's oxygen and metals strongly bonded together in minerals. And the idea is we develop processes, so it could be chemical processes, it could be gas processes, which enables at high temperature to extract the oxygen from the metal. Then we have oxygen that we can use for breathing, that we can use for refueling a rocket, for instance. And we have metals that we can use for manufacturing, for making tools and try to make construction elements. As of course we need a landing pad, we need roads, and for that we need to turn this dust into solid material. So we have also the processes for that. But these processes, for instance additive manufacturing, would be very useful for also shielding material, because you have constant radiation environment in space, you have radiation from the sun, you have radiation from space. So at the lunar surface you need to be shielded, otherwise long exposure to this radiation would be very harmful for the body of the astronauts. So all the habitat will have to be covered by a thick layer of lunar soil, and that's of course that will have to be consolidated, and there are also processes for that.
And so can these resources help us go beyond the moon, for example, if we want to go further into space?
Yes, so once we have, for instance, oxygen extracted from the soil, or if we can make use of the water that we find at the craters, then we can, in principle, refuel rockets in the vicinity of the moon that could help them to go further into space or bring more payload, as the gravity of the moon is 1/6 of Earth's gravity. So we could take advantage of this relatively low gravity to go further into space. But actually the real value will be the knowledge we acquire at the surface, as we will going to learn how to live off the land, how to be independent from terrestrial shipment. Because for the moon it's fine, we are about 1 week away from the Earth. But if we want to go beyond into space, we can't rely on Earth shipment every now and then. So we'll have to be completely independent, and that's what we want to learn at the moon. How to live off the land, how to really sustain exploration without counting on Earth.
And is this the type of research that you're currently working on?
Yes, so my work consists in developing all these processes to extract oxygen from lunar soil, or for construction, to turning this dust into some construction material. But actually, I'm working on identifying the knowledge gaps and trying to fill them, so we can take all these processes out of the lab and make them into space and make use of them into space for sustainable lunar exploration.
And can you tell me, how did you get involved in lunar research?
So up to my master, I have a background in material science. I had no connection to space. I did my studies in France, in Russia, and then I got an internship at the European Space Agency, and that's how I set foot in a lunar research environment. I followed with a PhD at the German Aerospace Center, and that's how I developed my expertise in processes for using lunar soil, and that's how I ended up at the European Space Agency as a research fellow today.
That sounds like a very exciting job. Thank you for joining me today.
Thank you.
If you'd like to learn more about moon research, stay tuned for our next episode about how we use these lunar resources in 3D printing.